Hi, this is a kind of an unscripted video for kind of extolling the virtues of the Rhino plugin called Panelingtools. I can't really speak highly enough of this plugin for interior students, architecture students, architecture practitioners, etc. It is just the cleverest bit of programming you'll encounter. Hugely capable. I'm just going to scratch the surface of it just now. So it has kind of two modes. You can kind of create two-dimensional patterns, or you can create three-dimensional patterns of panels or shapes, or custom shapes as well. So let's just kind of quickly look at the kind of 2D aspects initially. So you need to start off with some kind of surface. It can be very complicated shape or super simple like this one here. Okay, so what I'm going to do is just go straight to the plugin, Panelingtools, and create a grid. So create a paneling grid. Easiest one to kind of get your head around is surface domain number. So it's just going to divide the U and the V directions on this surface. So the default is to do it 10 by 10. So let's just run with that each time, because otherwise it'll take a bit too long. So we're saying, yeah, okay, just go with that. Okay, so we don't really need to see the surface now. It's going to kind of cloud things a wee bit. So I'm just going to go back to 2D and just switch off that layer. Okay, so if this was a single panel, then it would be numbered. So if it was just a single panel, these would be the reference numbers for it, and the rest of the panel picks up on these numbers in the two directions. Okay, we'll come back to these later on because it's kind of critical to the way things work. Okay, the grid is always square, four-sided in nature, and the spread of the dots depends on which method of creating the grid you've chosen. So let's just give it a go here. So Panelingtools, let's have a look at 2D here. Panel 2D grid. Okay, select paneling points grid. So you have to keep your eye very closely on what's happening in the command panel here, because there's lots of settings. Okay, so you pick on the grid, press enter, or select the base surface. If the surface isn't visible, it's okay, you can just press enter if there isn't one. Okay, and here it's gridding this up, and the pattern it's going for there is triangle. Got box. You just keep trying these out, whichever one you want to go with. So let's say we'll leave it on diamond, and the other options here, do we want to see the edges? Let's say no. Borders, we'll say no. Faces, yes. Flat faces, they're going to be flat anyway because it was a flat surface to start off with. Okay, and we've just got no for the meshes as well there. Grouping, advisable, and name at the end, that means it's going to create a layer in the layers list for that particular thing. So just press enter. You can see here we've got panels, and if we shade it, we've got surface. Dead easy. Okay, and that can be applied to whatever base surface you're starting with. Okay, you can either delete the object here, or you can come over here and right click the layer and just delete it, and it will take the objects as well. Yes to all. So you see here it says PF, so that's panel faces. So if we'd added the other ones, there would be additional layers there as well. Okay, I'm just going to switch the default on and show you another feature of this in a kind of semi 2D way. So let's put a grid onto this object. Okay, so this is twisting in all sorts of directions. Okay, so pretty nasty shape to try and panel. Okay, Panelingtools, create a grid. Let's just use the same option. Okay, so we've got 10 by 10. Okay, let's get out of the shading and switch default off for a second. Okay. I hadn't pressed enter there, sorry about that. Let's just get the grid back. Let's get the surface back. Hadn't finished the command. Panelingtools, create paneling grid, surface domain number, enter, enter. Right. My mistake. Okay, I'll switch that off. Okay, Panelingtools, paneling from grid, panel planar quads. So, you know, if you were using a material like glass and you were trying to put it onto a surface like this, you know, how many sheets could you put on before you'd have to contemplate moving the points? Okay, so panel planar quads, select a grid of points, enter. Okay, the base surface is missing, so we'll just press enter again. And we've got a deviation allowance here. So what we'll say is we're not allowed to deviate the points at all. If we have triangulate yes on, that's easy. Any surface could be triangulated. So we'll switch the surfacing off, the triangulation off, and then press enter. So you can see here it's only managed to put panels onto some of that shape where it's not too curvy. So if I shade that, okay, and let's compare that. Let's allow it to do some deviation. So I'll just delete that. Okay, Panelingtools, paneling from grid, planar quads again. Pick there, enter. Surface is missing, so just press enter again. But we'll allow it to deviate, say 0.2 of a meter here. Okay, enter again. Okay, so you see it's covered more, but it's crumpled. We've got crumpling going on here because you can see just how far it's had to move the points. So the blue points were our original ones, the black ones here, these are the new points to try and get more of these planar panels in. Okay, and this is why you don't see many square panelled curvy buildings. Okay, because it's just, unless you set up the geometry so that it's all kind of concentric and offsets of curves, you just can't do it. So that's why you end up with triangulation. So Panelingtools, paneling from grid, planar quads. Okay, enter on that, enter again, but let it triangulate. Put the deviation back to 0, enter, enter again. The whole surface is covered now, but as you can see, big chunk of them are split. So generally you would say, well, if we're going to have to split all of these, we may as well split the whole lot. Okay, and therefore we could just use the standard kind of triangulation patterns instead. Okay, so just wanted to demonstrate that. It's kind of like a halfway between 2D and 3D in a way. So let's look now in more detail at the 3D aspect. We'll leave that grid there. We can use that one again in a moment. I'll put this back on, and I'm just going to switch this grid off for a second. Okay. So 3D is much more fun. So let's say we've got a single panel. I've got points at the corners, just exaggerate them a little bit, and these have got reference numbers. Okay, so it's usually in this direction, so it would be S00, S01, S02 in this way. Up here it's S01, 0, and then it would be 2, 0, etc. Okay, but these then get offsetted, so you can see these points are pulled out. So generally we offset the grid to create a zone, so it's like a cell, a 3D cell. Okay, and the point references, they get offset as well, so we have a second set of points with the same numbers. So these have to match. If there's one of these missing, then it's going to fail. It won't do it. It has to have exactly the same number of points in each grid. Okay, so that's the kind of logic behind it. What happens is that we fill that zone. Okay, so I'm going to switch on. We've got a sphere object here, and so let's switch off these other ones, and we'll grid this up properly. Okay, so paneling tools, create paneling grid, surface domain number. Okay, we'll go with 10 by 10. Enter again. That's what I forgot to do last time. Okay, and what we didn't do last time was offset the grid. So that's grid utility, offset the points. Okay, I'm going to go with the distance of 1. Oh, let's make it 2 so it exaggerates it, so we see a bit of stretch on the spheres. Okay, distance of 2. So we'll select the points to offset, and then enter. And then it needs to know which direction, and that's usually picked up from the surface. So if we wanted them to go behind, we would have had to put in a negative offset. But here, this surface is pointing, the normal is pointing this direction. So if I click it, the offset should happen in that direction. Okay. So you can see here we've got 4 points on the surface there, and they correspond to these 4 points above. So they're the ones in the air, and then this one, this one, this one, and this one are the points on the ground. Okay, so then what we'll do here is paneling tools, paneling from grid, panel 3D grid. Okay, so we're only going to put in one object into all of these cells. Okay, so panel 3D grid, wrong one. Paneling tools, paneling from grid, panel custom 3D. It's not variable because we're just using one object. Okay, first bounding grid, the one on the surface, enter. Second bounding grid, the one in the air, enter. Okay, we don't have a bounding surface, so we just enter again. Select the object, that's our sphere here, enter. It shows you how it's going to repeat it. There is a little kind of a preview here. It's done a 2x2 repeat there. Okay, and then we enter again to finish. And there we go. So they look like kind of lozenges or something now, but it's just filled the cells with the spheres. Okay, so let's delete those. It's not gridded it. I didn't group it. So I'm just going to undo that. So we'll make sure I remember to group them next time. Okay, now the offset is quite high, so I'm just going to reduce it and just put the offset to 1. So paneling tools, grid utility, offset points, distance 1, enter. Okay, click the grid. Enter, base surface, so it gets up, picks its direction. Okay, so we've got our cells. Now what I'm going to do here is just go back to 2D wireframe and switch on these bounding boxes. Okay, now what these do is help kind of control the height of an object. So imagine this is the cell that we've got here. The sphere will look pretty normal, okay? Whereas if this was the cell, the sphere will be squashed by half its height. And the third one, if this was the cell, the sphere will be squashed to a quarter of its height, because it's going to fit this into this. Okay. So let's give this a go. This requires a bit more care. So paneling tools, paneling from grid, custom 3D variable. Okay, same start. Pick a grid point, enter. Second bounding grid, here, enter. Now we've got distribution methods. We've got a number of different ways of distributing. So for this one, I'm going to change the distribution method to point attractors. Okay. Don't need to change anything else. Group yes, that's good. Didn't group it last time. Enter. So point attractors, all we need to do is just pick maybe 2 or 3 points in view. So maybe one there, maybe one here, and one down here. Let's go right to the edge. Enter. So what will happen is that the first object we choose, let's say we choose this one first, they'll be clustered around these points. Then we'll get the second object. Then we'll get the third objects in further away. So let's see how this goes. So we've selected the attractor points. Now press enter. So module object 1 is the sphere. Enter. Then the bounding box. Enter. Module object 2, sphere. Enter. Bounding box. Enter. Module object 3 is a sphere. Enter. Bounding box. Enter. Then it offers us the chance to pick more. We've kind of ran out of objects, but you could keep picking the same one, and so you would have lots more of the flatter sphere. So let's just do that, another couple. So object number 4 is going to be the same again. Enter. Same again. Enter. Same again. Enter. Same again. Enter. Let's say we're done now. We don't want an object number 6, so you just press enter. We don't want the module number 6. Oh, it's done. Okay, if I shade it, you'll get a better idea of what's going on here. So you can see the clustering of the height of the full sphere is near the attractor points. Okay, now this is great, but it's not very interactive. When you use paneling tools combined with Grasshopper, it becomes much more interactive. You can move the attractor points around, and the model basically reacts as you go. But you can see, just the amount of kind of labor that saves in trying to distribute things, and distributing things randomly as well is really quite tricky. Okay, so finally what we'll do is something that's got a bit more kind of geometry in it. So let's just go back to wireframe, and I've got a few layers here in fancy panels. I'll put this file on, a link to it in the description, so you can play with it yourself if you want to get to learn how to use it. Okay, so stick my fancy panels on. Okay, so we're going to put them onto this surface, and instead of point attractors, we'll use a curve attractor. So this is a shape that's been drawn on this surface using this command, interpolate curve on surface. Very clever. Okay, so let's zoom in here. As long as we can see the curve, we should be able to get this to work. Okay, so what we'll say is that the red object is going to be the one that's clustered near the curve. So we'll pick this one first with its bounding box, and then move to the flatter object down here. Now these are quite detailed objects. If I switch these bounding boxes off and just shade this just now, you'll see there's quite a bit of detail in these. So when it does generate, it's going to morph. It's going to take time to make this all fit and morph to the grid. Okay, bounding box is back on. Okay, I need to see the curve, just a little bit of it is enough. Okay, then we'll offset we need an offset of the grid. So it's paneling tools, grid utility, offset points. Okay, pick the grid, enter, select the base surface, distance 1, yeah, let's stick with that. Okay, so we've not got much height there, but it's enough. It's enough for it to be legible. Okay, That's has got our 2 grids. Okay, just push that to the side a wee bit. So paneling tools, paneling from grid, custom 3D variable, point on the first grid, enter, point on the second grid, enter. We don't want point attractors, we want a curve attractor, enter. Select the curve attractor, just need to pick it there, enter. Okay, what I'm going to do is a lot of the flat one. Okay, so just 1 red, 1 purple, 1 blue, 1 green, 1 white, but 5 black. Okay, so module object 1, enter, bounding box, enter. Module object 2, enter, bounding box, enter. 3, enter, bounding box, enter. 4, enter, bounding box, enter. 5, enter, bounding box, enter. 6, enter, bounding box, enter. And keep going. 7, 8, 9, 10. I'm not going to do 11. 2 enters. We'll have to wait a few seconds because there's a lot of geometry going to be generated here. Okay, if I shade that, again having to think quite a bit. The initial surface is still on, so we can't see through these holes, but if I switch that layer off, you can see we're able to look through those holes. So there's a huge amount of modeling and distortion gone on there. But the highest of my little chimneys is clustered above the curve, and then we've got quite a few of the flat panels. Don't think we get one in that back corner, not quite. So you maybe need to do 7, maybe 8 of these before we just get less of the taller chimneys. There'll always be the taller chimneys on the curve, but it's just how many of these you kind of force into the distribution. Okay, one thing to watch out for. Okay, it's hard to tell, but that is straight, as is this, as is this. Okay, it doesn't twist the panel, it doesn't kind of morph it to the actual original surface curve, it's just going from point to point. Okay, if you need these to be actually curved as was the original surface, then you basically need to kind of set this up as a flat distribution and use flow along instead of paneling tools. So you're kind of adding another layer of kind of work to the job. So you do need to use paneling tools to get the distribution, but then you have to use flow along to get it to fit the original curve. So it really is very, very good fun, creative. You just got to get playing with it, and you'll fall in love with it, as I have. Okay, hopefully that's enthused you. If you use a Mac, its paneling tools is built in to the Mac version of Rhino, but in the Windows version you need to go to Tools, if I can find it again, Package Manager, and you need to pull in Paneling Tools. So if you just type panel, it should come up. There we go, Paneling Tools, and then you can install it. Okay, it's written by Raja Issa. She's one of the chief kind of programmers, mathematicians at McNeil. Absolute legend. Okay, folks, thank you. Cheerio.